Hello, welcome once again to our Java programming sessions. Today we're going to extend our previous discussion about a car class, and we're going to create a system of cars, so to speak, with our car class just being our superclass, or maybe also known as our parent class, or sometimes referred to as the base class. It goes by all those terms. Well, hopefully you watched our previous video and saw the short discussion of this car class, so I won't go over this again, but if you have any trouble understanding this, please make sure you visit that first video. It's relatively short, about 10 minutes or so, and it just gives you a quick review of things you learned back in Chapter 3 that you really need to understand to do well in these chapters here in the opening sections of the Advanced Java class. So here's our car class. It is what's known, as I say, our base class, our super class. And let's see here. I might be able to find a diagram for us to look at. There it is. Our class hierarchy for our car class. Our car class is on top of the hierarchy. These other classes that we're going to build are going to inherit from our car class. This will be the parent class. These are the children, and if you want to extend that, this is actually the grandchild of the car class. So we're going to show you how to do some programming here that will allow these subsequent classes to share in the previously defined parts of their parent class. Remember, this top line is the parent or superclass. A superclass is a good way to think of it. And this class down here is both a child and a parent. The sports car class, because it is a child of the car class, it is a parent to the roadster class. So in effect, the sports car class is a super class to the roadster, but they all inherit from our top class here, the car class. So this is the top, and we kind of read these arrows up the tree like that. So let's see how we're going to program that now. Well, let's look at the limo class first and see what we need to change, or how we need to change or code that so that it will inherit from the car class. Notice that I have made no changes to the car class from our previous discussion. It stays exactly like it is. So to be a parent class or a super class, you don't really have to do anything. It's what's the other files that they'll do that will make you a parent or a super class. So in our limo class, this is our limo class, and the most important keyword, if you will, is right up here at the top. Public class limo extends. That's the keyword we want that you need to know. Extends car. Now, what that line does, extends, it means that this limo class inherits everything from the car class, just as a child would inherit from its parents. So we'll notice that this class, as we look at its code, will be, although this is not always the case, but in this case our limo class will actually have less in it than our parent class, but it will be able to use all of the parent's capabilities, so to speak. Now notice we have our typical parts of any well-formed class. This limo class extends car, and in addition to it, it will have a length as well. Notice that this is set as private. In our constructor for our limo, remember this is our default constructor, no args. Notice the first thing it has to do to make this whole process work is to invoke or call the superclass's default constructor. This is another way of calling that car constructor that we see here. Our car constructor right here is going to be invoked by that super empty parenthesis empty argument list. Then we will set our own instance variable, the length of 210. What this does here is it takes the super's variables and gives them default values and allows then the limo class to have access to them in a fashion. Notice in the second constructor here for limo, where we are sending it, in this case 3 items, we're sending it a new manufacturer, which actually refers to our parent, a new number of doors, also from our parent, and a new length, which is local, which is to this class here. It's a class variable and instance variable to this class. Notice then in the first invocation here, underneath that constructor, we're going to call the super. Again, this calls the car constructor that takes 2 arguments. And then the last thing we'll do is we'll set our length to this new length that was sent to us. Now in our set methods, all we need is a single set method for our limo's length for that instance variable, because the other set methods it will inherit. It will inherit a set manufacturer and a set number of doors. We can see here we do a quick edit in our set methods. Remember, we've said before that set methods are really the places to put your edits, so that when they mutate the data, you make sure the data is correct. So we'll say if our limo here is not at least 210 inches long, we're going to set it to 210. Else we'll say our length is our new length. So we'll take limos that are longer than 210, but none that are shorter than 210. We assume that's in inches. Our set methods. Notice again, our get method. We only have one. That's get length. Again, a pretty typical get method. Return access modifier, return type, name, empty arguments list, and then the return that length. The only other thing we need to look at is our toString. We will create a toString for each of our child classes, because each of our child classes will have an additional instance variable to display. But notice how we'll display the number of doors in the manufacturer in our toString for this inherited class, for this class that inherits from the car class. We will call the super toString, which again goes one line up that hierarchy, goes to that super or that parent class, and first of all it will execute its toString, and then get away, there we go, and then it will come and print its own instance variable after it goes to a new line, and that ends our class. Now in this case I've put together, we had for our previous example we used the car tester file, if you'll recall. This time I'm going to use a slightly different one. I'm going to call this one car driver. Now you will find all of this code in the folder that accompanies these videos, so make sure you look at this code and enter it as well. Besides just reading it, it's always good to get it under your fingers, get it into Eclipse or whichever IDE you're using, and make sure that you can really get things to run. So in our main method here, just some bookkeeping work there. First of all, let's review a few more things you learned back in your first Java class. You notice here line 12, we are going to be declaring an array of cars. An array of cars called myCar, and notice that the syntax there for this car array, the square bracket you'll recall, and then we'll say we're going to create 4 new cars, 4 spots for this array. Now remember, this does not exactly create the car itself, it just creates the array. Notice we haven't called any car constructors here. What we have called though is the Java mechanism to create an array that will hold car types, and in this case we want to hold 4 of them. But remember, right now we haven't created any cars, but we're going to do that in a second. And there's our first car. We're going to create a car at spot 0. We're going to call it a new car. It's going to be a Ford with 3 doors. Now notice again here that we saw this in our first example the other day, that this is going to create, called the non-default constructor, create a regular old car of Ford, and this time though it's going to stick it in that 0 location, or in other words that first location of this car array. We got to give a couple more lines here before we can really see it in action. Well, there's going to be our first car's toString, but that's nothing new here. This is what we want to get into. This again is all from our first example the other day. But now we're creating a new limo. Notice that what we're sending it is 3 pieces of information. It's going to be a Ford, it's going to have 5 doors, and it's going to be only 28 inches in length. Let's see what happens when we run that. Give me just a second to scoot this down. Come on, you can do it, buddy. There we go. Okay, so now I think we have enough here to run it. Let's go up to our run mechanism, or our play button if you will. It's going to select the resources to save. It's going to save our car driver. It recognizes some changes since the last time this was opened. It saves my changes. It runs it, and again, remember, you're going to look in the console window here if you're using Eclipse for your output. That's my little bookkeeping Java class hierarchy. And here's our first example. The manufacturer is Ford, and the number of doors it has is 3. Here it says the manufacturer is Ford, and the number of doors it has is 5. Oh, we've got an extra period there. And the limo's length is 28 inches. Now, we just said before that we don't want our limos to be less than 210 inches. So let's see what went wrong in our reasoning here as we try to debug this kind of small error, but one that we want to present to you first so that we can get you thinking in ways that trap your mistakes and trap your errors. So let's go through here and find out what went wrong. We went to our limo and we called our default constructor in our limo class and gave it this information. Well, let's look at that default constructor in our limo class. Notice the default constructor in the limo class, as soon as I can get to it right there, has no check on length. It just takes whatever is sent to us and puts it in to our instance variable length. Well, that is okay if you know your data is always going to be good, but remember, as I just said a few minutes ago, that the place to put your data edits are in your set methods. So what we really want to do here in our constructor is not set that directly, but instead call our set length mutator, and we'll send it as data our new length. Now what this will do is it will invoke the set length method right here and go through this edit, and now it should give us our length of 210 rather than that 28 that we showed a second ago. Again, this was our first input right here where it said 28 inches. Let's run this again now and see what we're going to get. Well, now we get this. Excuse me. Manufacturer is Ford, and the number of doors it has is 5. Well, I still got to take care of that extra period. The limo's length is 0 inches. Well, how could that be? Well, let's go back once again and see what might have gone wrong. So back here at our limo method again, have you been able to find the error? Have you gone back and looked at our set length code and seen what might have gone wrong? Well, hopefully what you did see is that although we're doing a good check here of if new length is less than 210, what we're setting here is new length to 210. Well, we don't really want to do that. We want to set the instance variable here. Here what we're doing is setting the argument. Notice how Java color codes these as well. Not Java, but Eclipse. The instance variables are always in blue. So that if we put length in here, now that draws our attention to, oh, I'm setting the instance variable now, not the argument. Let's run this one more time, our car driver one more time, and see what we're going to get for our output this time. And now we get exactly what we want. The manufacturer is Ford, and the number of doors it has is 5. The limo's length is 210 inches. All right, well, let's go back and continue to look at this hierarchy, because we said before that I don't want to go too far. We're going to have more than just 2 cars in our hierarchy. Let's go now and create a sports car class. So if I bring up this class that I previously created, it's our sports car class. And for purposes here, our only difference between a car and a sports car is we want to track the color of our sports car. Everything works exactly the same. Where public class sports car extends car. Then we have one instance variable marked private that's color. Then we'll call our super in our default constructor, the super default. We'll set our color to red. Notice we're using the set color method rather than setting it directly here, as I just showed in our limo class. Next we go to our full arg constructor, new manufacturer, new number of doors, new color. We'll call that super's toArg constructor, let it do its magic, come back down, set our color to our new color. Those are our 2 constructors. Here's our accessor method, where we're simply returning the color, return color. Now notice we're returning our color is a string and not the color type that Java has. We'll want to keep that in mind as we see some other things this week. But this is returning just a string, not an actual color. And then down here we'll do our mutator method. We'll take one argument, new color, no return type, it's void. We'll again check if new color is empty, that means there's nothing in it, we'll set our color to red. Else we'll set our instance variable color to the new color. Remember, data always flows from right to left, from right side to left side. So this data is going in that direction. And then finally our toString looks the same. We'll return our super toString, and the color of the car is, and we'll give its color. Nothing different from our limo class, just another class so we can show you how this all fits together. So if we go back to our driver now, I can activate some more lines of code. I'm going to create a sports car now, put that in my third storage location. I'll call this a Chevy. Its color will be purple. It will have, well, let's change this. I don't want 3 doors again. I got too many 3 doors. Let's go with a 1-door sports car. Super fancy. Okay, let's run this and see what happens. Okay. Here's my output. Let's grab it up here so we can see it. And there's our new one. The manufacturer is Chevy, and the number of doors it has is 1. I still got to get rid of that extra period. And the color of the car is purple. Have you found out where that extra period's coming from? I know where it is. I just have been too lazy to go get rid of it. But I'll get rid of it here in a second. But I got to show you one more thing now, because now what we've done so far is created a car, we've created a limo, and we've created a sports car. The limo inherited from car, the sports car inherited from car. Now we're going to create one more type here, one more class, also known as a type, and these are going to be roadsters. Okay, the only difference on a roadster from a sports car, again, notice we're extending sports car once again, but we're going to add a foghorn, and this time we're going to say true or false, this sports car has a foghorn. If it has a foghorn, then it's a roadster. If it doesn't, then it doesn't. Okay, here's our constructors. I'm not going to go over those again. I've already covered them on the other ones. You can see how they work. Notice what we're calling, though, is we're calling the super all the time. Notice what super we're calling here, though. We're calling a 3-argument constructor. So think of how this hierarchy goes. In this 3-argument constructor, it goes back first to the sports car class, calls this 3-arg constructor. The sports car class, then the first thing it does is goes and calls the car class to the 2-argument constructor. These 2 instance variables get set. Then it drops back to sports car. The color variable gets set. And then it goes back to roadster. And finally, the foghorn value gets set. Here's our set method. No editing in there. We're just taking what they give us. Because for it to be a Boolean variable, it has to be either a true or a false. We don't need to edit for that. We know Booleans can only hold those values. So therefore, we know that we don't really need an edit on that. We'll return our fog just as before. And now look, one thing here in our toString. Once again, we're going to return the super toString. But once again, remember, this is going to call, first of all, its super is the sports car. So it's going to call the sports car toString. The sports car toString is first going to call its parent. It's going to go back to car. It's going to print this information first, the manufacturer and the number of doors. Then it's going to go back to sports car. It's going to print, go back to sports car. It's going to print the color. And then it's going to go back to roadster and print the foghorn value. Let's see, I think I activated that in my car driver, did I? No, I didn't. I got to do that now. Let me move my comment here. And this, notice, takes up the 4th spot in our array, 0, 1, 2, 3. That's our 4-spot array, so this will be the last car we're going to create. And we're okie dokie to go. Let's see what we get. Should be what we expect. I didn't have any tricks in here this time. Okay, so this is our last invocation. The manufacturer is Lincoln, and the number of doors it has is 4. The color of the car is black. Notice my two periods there again. And it is true that the car has a foghorn. This one has a foghorn because we can see when we created this one in our driver. I almost had a car wreck. when we created this in our driver, we sent it true for that foghorn value. All right, now, since these were two strings, or since these were all an array, what we can do and demonstrate the power of inheritance is let's comment out these values, these lines I should say, and instead we're going to activate now a for loop. A for loop is easy to use with arrays. You remember we can use enhanced for loops with arrays too, but this is just a straightforward for loop. Whoops, hold on. Went the wrong direction. Dagnabbit. There we go. And so what we're going to do here is go through our for loop 4 times, starting at 0 up through the car length. You'll remember how you did that in your opening Java class. We're going to print out my car array as subscripted by its index, its toString. It will know which type is in each of these arrays and call the appropriate toString. Let's see if that works as advertised. I bet you it does. And you can see now our output looks like this. There's all our toStrings called through that loop. I'm not sure where that 28 came from, to be honest with you. That's a mystery to me. I'm going to have to look at that. Oh, the mysteries of computers. I'm not sure what that 28's doing hanging out there, but I'll look at it and maybe get back to you. Maybe you guys will figure it out. Now, there's one more thing I want to show you, and we'll end this lecture. There's one other thing we can do. We can find out what type a certain object is. And we can use this instance of. We can go back and go through our for loop, one item at a time. We will then check each car via its index, 0, 1 through 1, 2, and 3. We'll see if it's an instance of sports car. If it is, we'll print this line, this car is a sports car, else we'll print this line that it's not a sports car. Now remember, if we do have just a sports car category, and we also have a roadster category that inherits from sports car. So let's see how it's going to handle that little bit of information. So we can type classes using this instance of, find out their types. And now let's see if I can get this all on my screen. It's not easy. There we go. My car 0, that's the Ford, that's our base car. It's not a sports car. My car 1, that was our limo car. That's not a sports car. My car 2 was our sports car directly, so to speak, and it's listed as a sports car. And the last one then was our roadster, and it comes down, this is our roadster, and it says my car 3 is a sports car, and that's true because you know, my name's Riley, my parents were Riley, and so I inherited that. So what you inherit from your parents, that is what you are. So that's what this car is. It's a sports car because that's how it started out life. It inherited from sports car family, so that's whose family it's part of, and that's whose class it's part of. Now, like I say, I urge you to enter this code, make it all work. You'll find this will be helpful as you work through Chapter 9. There'll be another lecture yet this week. Stay tuned. This is only our first one as we get things geared up here in this semester. So I hope this all helps. Remember, if you do have problems, post in the online discussion board. That's the best way to get help rather than email, because everybody can see your questions and we can all help and work on each other's problems together. So this is Owen Riley saying we'll see you next time. I hope this has helped you become a better Java programmer than you were, say, a half an hour or so ago. All right, take her easy, all. Later.